I'm Anil Kumar sharing with you solution of a question from my student, and I hope its solution will help many. The question here is 10 people are to be seated at a rectangular table for dinner. Tanya will sit at the head of the table. Henry must not sit beside either Wilson or Nancy. In how many ways can the people be seated for dinner? You can always pause the video, answer the question, and then look into my suggestions. So, order is important in this particular case, and therefore it's a case of permutation, right? So we look into permutation with 10 people. So let us say these are the 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, out of these, we are given that Tanya will sit at the head of the table. So one person is fixed. We don't have any combinations. We cannot place this person anywhere else. So this is fixed. We're left with now 9 people. In these 9 people, we have Henry, which must not sit beside Wilson and Nancy. So we have 3 special people, Henry, Wilson, and Nancy, right? So we'll not like to have this kind of a combination. So amongst these 9, we have 3 of these, plus 6 others who have no problems. So we have 9 plus 1, 10. We'll look for the possible number of combinations which all of them can make. Okay, so let's work out with cases. So in the first case, I will take Henry at first position, right? So let's do case 1. Case 1 will be when Henry is in the first position. Let's say we have now 9 here on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Tanya is fixed here. And we are placing Henry in the first position. Since Henry cannot sit beside Wilson and Nancy, so we cannot take these 2. We are left with 6 options. So the next position could be taken by any 6 of them. Any 6 of these 9, right? So Henry has been fixed. 6 others have been taken care of. 1 out of 6 have been taken care of. That means out of 9, 2 have been taken care of. We are left with 7, which can take this position. Once that is taken care of, then 6, 5, 4, 3, 2, 1 is the number of persons who could take the respective positions. That gives you what number? So that gives you 6 times 7 factorial. Is it okay? 6 times 7 factorial, which is equal to, let's calculate this value. 6 times 7 factorial, which is 30240. Now let's look into the other scenarios where Henry is not at the end position. Well, that brings me to the end position here also. We could have case 2. Let's take case 2, where we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We know Tanya is fixed here. And let us take Henry to be in the last position. So that scenario is very similar to this. Nancy and Wilson cannot sit by the side of Henry, so we're left with the option of these 6 people. Once 2 have been taken out of 9, we are left with 7. So we could write 7, 6, 5, 4, 3, 2, 1. And that gives me again a combination of 6 times 7 factorial, which is 30240 arrangements, right? Now let us consider the positions where Henry is sitting somewhere in between, right? Okay. So case 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us say Henry is sitting in the second position. In that case, how many can sit in the first position? Not these two, only 6 of those could, right? So 6 here. Once one of these 6 have been taken care of, we are left with 5. So 5 can be on the other side of Henry. We have fixed 3 people out of 9. So how many can come here? 6. And then 5, 4, 3, 2, 1. Correct? So that gives you the number of combinations as, so we have 6 times 5, 30, times 6 factorial, right? 6 factorial. Let's figure this out. So we have 6 times 5 times 6 factorial, which is 21,600. Okay. Now look here. If Henry sits in this position, situation is same, right? All these positions, situation is similar. So those will be the combinations for Henry being seated not in the beginning or at the end of these 9 people, correct? How many such positions are there? 1, 2, 3, 4, 5, 6, and 7. Therefore, this number should be multiplied by 7 for all those positions, correct? So let's do it. So we have 21,600 times 7, which is equals to 151,200, and we already have these two, so let's add them all, right? So total number of combinations are 3240 times 2, you can say, right? Times 2 plus 21,600 times 7. Does it make sense to you? Right. So let's do this. So we have 3240 times 2 plus 21,600 times 7. That gives us the answer as 211,680. So that is the number of combinations which you could have in this particular situation. I'd like you to go through this video once again, understand what we did. So whenever we have some unique situations, it may be better to consider cases. And also, as we move along, it is a good idea to find similar cases. Do you see that? So these two cases are similar, Henry being at the first position or the last position, and then we have similar 7 cases where Henry is in between, right? So I hope that helps you to understand and figure out how to solve such questions. Thanks for watching. Feel free to post questions, and if you like, that'll be great. Thank you and all the best.